9.9 covers scatter plots. We'll interpret different scatter plots here today. Scatter plots is basically a graph, and it shows if there's a relationship that exists between two sets of data. So one set of data would be your y-axis, the other set being your x-axis. You'll also draw a line of fit. A line of fit basically is very close to your data points. You're going to have some above and below the line, so you try to when you draw that line of best fit, about half above, half below. But basically, it's used to predict for our graph to determine the relationships that we have. 3 different relationships. You'll have positive relationship, negative relationship, and no relationship. Look at those graphs. Well, in a positive relationship, as x increases, y increases. So your line of fit would be something like this. And again, remember, the line of fit just helps us predict about half above, half below. Negative relationship. As x increases, so as x increases, we find out that y decreases. So here's x increasing and y decreasing, and there would be your line of fit, about half above, half below. No relationship there, so there is no pattern. It's just all scattered there, hence the name scatterplot. Alright, in example 1, you're going to identify a relationship from those 3 relationships. Explain whether a scatterplot of data for the number of cups of hot chocolate sold at a concession stand and the outside temperature might show a positive, negative, or no relationship. So we have number of cups. Hot chocolate is listed first, kind of like your ordered pair, x, y. So x is talking about the number of cups of hot chocolate. And then the outside temperature is your y value. And then we would need a title for this graph here. So we could say hot chocolate and temp. Now, if you think about it, as your temperature, your y value increases, the temperature, it gets hotter. As this temperature is increasing, normally, if you think about it and you come down, you would not have that many cups of hot chocolate. The hotter the temperature, the less hot chocolate sold or drank. So as the temperature would decrease, the more cups of hot chocolate that would typically be sold. So I'm just kind of filling in some data points here to kind of get an idea of what would happen pertaining to the number of cups of hot chocolate and regarding temperature. So if you look at this, your relationship is negative. It is going to decrease. And again, about half above, half below, but a lot of points should be near the line. You may have a point that could be considered almost outliers, but typically you're going to see that trend or that pattern, and again, this pattern would be negative. Example number 2. In this graph here, the plots are already given for us. It says, explain a scatter plot of data for the birthday and the number of sports played. Might show a positive, negative, or no relationship. Well, it gives us that our axes are already labeled. Sports played is our y, birthday is our x, and then our scatter plot is already in there. Just looking at this, there would be no relationship. There wouldn't be a line of fit to draw in here because I couldn't get about half above, half below, and it doesn't look like it's increasing or decreasing. The only other thing that's missing in our graph is our title. So I'm going to go ahead and title it, and that would be B-Day. We have our birthday and sports played. So B-Day and sports. Need to have a title for that graph. Example 3, we're going to record some height and jump heights of our class here. So this will be a classroom example that we'll fill in. Here's our classroom data just from some students, our heights and jump heights that we have recorded. Next, we're going to go ahead and use these recorded values for our graph. So here's our graph. We'll want to label a title and both our axes. So if you look back at that table, our height was listed first, so that would be our x value. So here is height, and that leaving our our y value jump height. And another good thing to put down here is that all of these are in inches, so we know the label, the measurement. And then we'll need a title, so I'm just going to say height versus jump height. And then I want to go ahead and put my intervals, determine what is my jump height that I need to get to, or actually my height. The highest height that I have in my class there looks to be about 69. Actually 70 is our highest point, so I want to make sure that my x-axis can stretch out to 70, so maybe I go up by 5s. And it looks like I'm going up by 10s, but remember, I need to determine what every line represents, so I'm going up by 5s here in my graph. On my jump height, what I'm going to use is called a broken line. That's basically telling me, or telling you, that I am not going to start at 0 here. So here's my broken line, and I'm not going to start at 0. Maybe I start, my lowest value is 83, so I'm going to go ahead and start at 80, and I'm going to do the same thing and go up by intervals of 5, so I can get up to my highest point on my graph. Next, I'll just go ahead and plot my points. So my first height there is 69 with a jump height of 94. So I'm going to hit just below 70 and go up to about 94 on my graph and put a plot. So it's about right in there. So I want you to go ahead and fill in the rest of our plots. So now we've plotted our points here. The next thing we need to do is go ahead and draw a line that best fits our data. Well, it looks like it does kind of have an increasing pattern. Again, you'd use a straight edge. When you try to draw a line of best fit, try to make it go through 2 points. That way you can find the slope, y2 minus y1 over x2 minus x1. So I'm going to go ahead and try to go through a couple points. And again, maybe half above, half below. My line of fit would look something similar to that. And remember, that would use to help predict our data. So this would conclude our classroom example for the line of fit. In example 4, we're going to use the information from zoos in the graph of the average and maximum longevity of various animals in captivity. We're going to write an equation for the line of fit. Here's how we're going to do that. First step is to find the slope. So use 2 points that we know. And we know how to find slope. We've been doing a lot of it. So find 2 points that we know exactly what they are. Here would be a good one. This point right here would be 15 and 40. Another point on that line that I know exactly what it is. I can use this point, but I don't know exactly what it is. So I would prefer to use this because I know exactly what that is. That is 35 and 70. So 35 and 70. So we'll use those 2 points and find the slope. Following our substitution there to figure out our slope, we'd wind up with 30 over 20. Which would reduce to 3/2, and remember that is y over x, so that is basically taking maximum of 3 years over the average of 2 years. Our next step is to go ahead and find the y-intercept. So in step 2, we have that equation y equals mx plus b, and there's 2 ways we can use that, or you can use point slope because you have a slope. Here is slope, here is a point. And you could use that equation for point slope and then convert it to slope intercept form. I'm going to go ahead and use find the b value since that's what we have in our instructions. So I'm going to say y equals, our slope is 3/2 x plus b. Put in a value for x and y. That is one of our ordered pairs. So I'll use that first one. I'm going to put in 40 for y. And I have 3/2, and I'm going to put in 15 for x plus b. Now I'm going to solve for b. So we have 40 equals, we have 3/2 times 15, which would give us 22 1/2, and that would be plus b. Get b alone. In order to get b alone here, we would subtract by 22 1/2 on both sides. And now on the right side of my equation I have b, and 40 take away 22 and a half is 17 and a half. And your last step would be go ahead and write it in as an equation, which would be y equals 3/2 x plus 17 and 1/2. That would be your third and final step, putting it in slope-intercept form. Our last step in example 5 is to go ahead and use the graph to determine. It says zoo is the average graph, shows the average and maximum longevity of various animals in captivity. Use the equation y equals 3/2 x plus 17.5, which is actually what we figured out in the prior example, to predict the maximum longevity for an animal with the average longevity of 33 years. First example says use the graph, so you actually have to use the graph. You're going to figure out when it has an average longevity of 33 years. So I'm going to come over, figure out where 33 is. 33 is about right in here. I'm going to go up until it hits my line, which is about right there, and I'll come over and I'm going to say it's about 68 years. And again, that's just using my graph. Now the next part, it says use the equation. Well, the equation is y equals 3/2 x plus 17.5 that they give us. So we want to put in 33 years, and that is an average longevity. Average is in the x-axis, so you're going to put 33 in for x and solve it. So I'll say y equals 3/2 times 33 plus 17.5. Do your computation and you figure out that y would be equivalent to 67 years. So we're close using the graph, but obviously using the equation is exact. This will conclude 9-9 scatter plots.